So in this example, we're going to take a look at polynomial division, specifically long division. We've already looked at what happens when we divide polynomials, specifically quadratics, or even linear functions when they factor nicely. And today we're going to look at what happens when they have a remainder. And you probably saw this first when you're in elementary school, and it's something that is difficult for students. So I'm actually going to go over an elementary school problem before I go over the high school problem, just to refresh your memory of how this works. So the thing that is being divided itself is called the dividend. The thing that's doing the division is called the divisor, and the answer is called the quotient. And the first thing that's strange is we write the 12 here, and then we make this symbol. It's kind of like, it's just a place to work, right? That division symbol. And then we put the dividend inside. And the way that we start this process that's really important is we actually ignore anything that is not going to be a group of 2 at a time from left to right. So when we start this problem, we're just going to take a look at 12 and see how many times it goes into 61. We ignore this temporarily, and we just do this problem. It's really important for the algebra as well. So when we do this, 12 goes into 61 5 times, because 12 times 5 is 60. And then we take that and we subtract it. And that's an important thing to remember too. We're always actually subtracting while we do division to figure out what the next term is. So 61 minus 60 is 1. That's our first remainder. But we don't stop because we have another digit we can carry down. And we carry that digit down, and then we start the entire process over again. But now we're looking at 12 going into 17, which will occur 1 time. Then we do the process again. 1 times 12 is 12. Then we again subtract, and we find our next remainder is 5. So after we know that remainder, we then carry down the next digit, and we get 54. Again, always having something that has the same amount of places as the divisor. So then we start the process again. 12 goes into 54. As a young child, you might have guessed 5 and then had to erase. We're a little more advanced now, so we know that it's actually a 4, because 4 times 12 is actually 48. And that frustration actually doesn't happen in the high school math, because you'll know exactly what to subtract, unlike in elementary school, you have to guess. So then we subtract this, and when we subtract that, we get our final remainder of 6. And many of you may have learned 2 things. You may have learned to say, well, the answer is 514 remainder 6. Can I tell you that is probably a bad way to ever think about that, because it's actually the modulus, and we don't write it like that. You might have also been told to put a decimal here and bring down zeros. I'm actually going to invite you to learn something new. You may have learned it in elementary school, but I find it to be a rare thing that students learn in elementary school, is to take the remainder and put it as the numerator of the final answer, and then divide the divisor, and then reduce that. So the actual answer, the quotient as it's called, is 514 and a half. There's really no need to do that decimal thing where you put a dot and drag it down. In fact, if you type it in the calculator, I typed it in Desmos, you can see right here that it comes out to 514 and 0.5, which is exactly right. That's exactly what this is. So that's a really important thing to understand, because that's the only way to do it in the high school version. So in the high school version, same thing. I have my divisor. I'm going to write it out here. If you want to write it in a parentheses, there's nothing wrong with that. And then inside the division symbol, I am going to put the dividend. All right, and then we start the same process. Notice that this is a binomial. So we're going to take this binomial, and we're only going to divide it into this binomial, not into the trinomial. Just like here, there's 2 terms. I want to do this with 2 terms. And the beautiful thing about this is, just like here, how we were really worried about the 60, here we're only really worried about the coefficient. So what you really have to ask yourself is, what do I need to multiply x by to get x squared. Here you multiplied 12 to get 60, and you picked 5. Here we're going to multiply x by something to get x squared, and that is x. Again, x times x squared, sorry, x times x is x squared, but you will have to distribute this because there are two terms, and then you have minus 2x. So x was picked to make it a square, then I distribute it to both terms and I write them in their proper location. Then I subtract, but unlike in elementary I subtract once, here I'm actually going to subtract both of them. Okay, so I subtract that one and this one. This one will cancel, this one will change to an addition, and this is our first remainder that we get here, which is 5x. Okay, and just like in elementary school, I now draw a line and bring down the remaining portion of the problem, so I put a minus 5 here. And then I start over, and I ask myself again, I only care about the coefficients, just like in this step, I cared about making 12, 17. All I care about here is making x become 5x, because I want to cancel one thing at a time. This part will be taken care of as you do the problem. So the way to make x become 5x is to multiply it by 5, and then to move this by distributing. 5 times x is 5x, that'll cancel in just a second. And 5 times negative 2, right, is negative 10. Now I'm going to subtract each term, subtract the first term and subtract the second term. This one will cancel. This one is changing to an addition sign. So my remainder is negative 5 plus 10, which is 5. So the reason that it was important for me to review how to do this right here is because it's the only way to do the answer here. The answer is to take the 5, the remainder, right? I'm going to just be consistent and make it red because it was red in the other problem. So I'm going to take that 5 and I'm going to put it right up here, a 5. And then I'm going to put on the bottom of it the divisor, which is x minus 2. Now, unlike in elementary school where I didn't need to do anything, since this is an algebra problem, I do need to put a plus here. And if it were negative, you'd put a minus. So the overall answer for this problem is x plus 5 plus the remainder divided by the divisor. And that's the easy process. One thing that I noticed as I was doing it that some people have trouble with is, why did I skip this thing here? The reason I skipped it, and it's a little, we did not put that 5, maybe I should move it over to there, because we did not put a number on the 6 either, because there are two places here, so we put our first quotient answer over the second value. So 2 things, I put the 5, 2 things over. Here I have a binomial, so I start at the binomial step. If I were dividing by a trinomial, I would actually put it here. So I'm going to take a look at another example. Okay, so here we go. We have this one again. This one's a little different because there actually are things missing. So up here, we have everything we would need to have in our polynomial. But down here, there are terms missing. And the reason that this is important is in elementary school, like let's say this was 2,103. You actually have this to hold the tens place. But here, do you see how there's no x? You have to actually include it. So the first thing you're going to have to do is you're going to have to rewrite the problem to include the missing terms. And you could rewrite it at the beginning if you want, or you can just do it when you divide. So I'm going to rewrite the divisor as x squared plus 0x plus 3. And yes, you have to do that because things won't line up otherwise. Then I'm going to divide that into, notice I'm missing the x to the third power plus 3x squared plus 0x minus 3. Okay, so notice that I'm missing those terms. The reason we do that is things will not line up if you don't put those placeholders in. Notice also in this case that I'm going to be dividing 3 things, so my first answer is actually going to appear right here because of the fact that I have a trinomial, so my answer will occur on the third term. So This looks like a whole lot to do, but you don't have to do a lot. Again, all you care about is making this coefficient become this one. So how do I take x squared and make it become an x cubed? I use an x to the first power. And then what I'm going to do is I'm going to multiply, distribute this times each term. And that's where that placeholder is really important. If you don't put that placeholder, things will be jumbled. But watch how nicely it organizes. X times x squared is x cubed, right? And then x times 0x is 0x squared. X times 3 is 3x. Okay, and then I will subtract each of these terms. Instead of subtracting 1, I'm going to subtract 3 different things, giving me my first remainder. These things cancel, right? 3 minus 0 is positive 3. Remember, we are subtracting, but we're subtracting positive 3 minus 0. Then I have 0 minus 3, which is negative 3x. And then I'm going to drop down this negative 3. So this is my, it's actually good to have a trinomial because there's less work because we started all the way over here. So again, don't focus on everything. Just focus on making x squared become 3x squared. I need to multiply by 3. I then multiply each of these things by 3. Okay? If you need to use the box method over here to figure that out, please do. It is kind of a mess, right? So we get 3x squared. Then here we have 3 times 0, which is 0x. 3 times 3 is 9. Now we will subtract each of these individually. This cancels. This is a negative. This is a negative. So we'll get our answer down here of negative 3x. Again, this is just a placeholder, so if you want to scratch it out, you can at that step. 3 minus 9 is negative 12. And this will be our remainder that we'll put right here, negative 3x minus 12. And then we divide that by the divisor, which was x squared plus 3. And we put a plus sign here. And a lot of students will say, why don't you use a negative? You've got to be careful. Here is one answer, x plus 3 plus negative 3x minus 12, okay, over x squared plus 3. It would be inappropriate to combine these and make it a negative. The way that you would have to do that is you would have to factor a negative 1 GCF out to make it 3x plus 12. And then you would combine those two together. So you would get x plus 3 minus this expression, because you just combined those things, removing it. So you get 3x plus 12 divided by x squared plus 3. So this is the fully correct answer. And on an SAT or a multiple choice test, I guarantee this answer will show up on an SAT. Or an SOL if you're in the state of Virginia, right? However, the other answer, where you did the plus and you left that part out, I mean, that would be acceptable. I wouldn't mark it wrong on my test because I'm glad you learned how to do long division. But you've got to understand that you may have a multiple choice, and on my test, this question may be a multiple choice, and this is the answer I'm going to present. So you really need to understand that, how that works, how that negative comes out as a GCF, right? GCF factoring is super important. It shows you how to properly simplify expressions.